In this video, I'm going to show you how to graph a rational function. A rational function here is y equals 2x divided by x plus 1. Now the first thing we're going to do is identify our asymptotes. So to find our vertical asymptote is when I take my denominator of x plus 1, set that equal to 0, and we're going to solve for x. So I'm going to subtract 1. That means I have a vertical asymptote, which means it crosses the x-axis at -1. So I'm going to come to my coordinate plane and draw my vertical asymptote at x equaling -1. Our next part is we're going to now find our horizontal asymptote. Now to determine if we have a horizontal asymptote, I'm going to take my numerator and my denominator and determine what degree they have. In the numerator, I have 2x, which means it's a linear function. And all linear functions have a degree of 1. My denominator is x plus 1. That's also a linear function, so that has a degree of 1 as well. If the numerator and the denominator have the same degree, you're going to take the leading coefficients, so of 2 and 1, and that would be our horizontal asymptote. So for this one, since I have the degrees the same, I have 2 to 1, my horizontal asymptote would be y equals 2 divided by 1, which is 2. So I have a horizontal asymptote at 2, crossing the y-axis, so I'm going to go to my y-axis, put my horizontal asymptote crossing at 2. Because I have a horizontal asymptote, I'm not going to have a slant asymptote, also known as an oblique. And therefore I will not have a hole as well. Now the x-intercept. To find the x-intercept, y would have to be 0. So if I put 0 in for y in my function, I'm now going to have 2x divided by x plus 1. Now we need to know what does our x have to be so this whole thing would equal 0. Well, when you have a fraction, the only way for the fraction to equal 0 is if the numerator is 0. So if I take the numerator of 2x, set that equal to 0, I can now solve for x. So I'm going to divide by 2, and I would have an x-intercept at 0, because 0 divided by 2 would be 0. So I have, when y is 0, x is 0. So I have a point at the origin of 0, 0. Now I want to do another point just in case, just to make sure I know where my graph is going to go. So when my x's increase, does it go towards the horizontal asymptote? I'm going to find that by putting in a number for x. I always go from where my vertical asymptote is, and I take the next closest x coordinates to the right of the vertex, the vertical asymptote. So if I already have 0 in for x, now if I put 1 in for x, 1 plus 1 is 2, so in the denominator I have 2. 2 times 1 in the numerator would be 2. So I have 2 divided by 2. 2 divided by 2 is 1. So I would have a point at 1, 1, 2, or 1, 1 for my next point. So I would have a point here. And it's not going to, in this case, it's not going to cross the horizontal asymptote. So I would have a line that comes close to here, and then it crosses the x-axis and follows the horizontal asymptote. Now if I want to keep applying more points, you will see that it follows that line. You don't have to plot that many points on there, just so you have an idea of where the line is growing. So I've done the first half. What about the y-intercept? Well, I already found the y-intercept because it crosses at 0 as well. So if it's at the origin, your x and y-intercept would be the same. So what about the left-hand side? To find the left-hand side, I'm going to choose x values. Again, I'm going to use since I have the vertical asymptote at -1, I'm going to put -2 in for x. So if I put -2 in for x, I have -2 times 2 divided by -2 minus 1, or plus 1. This is going to give me a -4 all over a -2. Actually, a -1, because -2 plus 1 is -1. -4 divided by -1 will give us a +4. That means I put a point at -2, +4, which that would be way up here. And then one more point, I'm going to choose 3. So if I put 2 times -3 all over -3 plus 1, so this is going to give us a -6 divided by a -2. -6 divided by -2 is a +3. So I have -3, +3. That would be here. So I know that it's going to get close to the horizontal asymptote, come up, and follow along the vertical asymptote. So that would be our graph for this rational function.